classical theists, like the people that believe in like an actual deity or like a mind that created the universe. What's your opinion on people like that?
Primordial form of idolatry is personalism. Maladaptive anthropomorphism just arises due to the flawed nature of subjectivity, imperfect, temporary nature of our existence. So I would say inevitable, sad, would like to assist and support people to move towards a state of personalism, um, without vibe of like forcing them.
All right, strong atheist. Go ahead. Any questions?
Yeah, I just was listening to you say that everyone decides things based on emotions, and I can't see as atheists do that. Can you explain that, please?
Everybody does things based on emotional reasons. Usually it's a desire to be perceived as intelligent. Also could be desire to conform. Those are emotional drives. So is the desire for knowledge. The desire to be perceived as intelligent and the desire for knowledge come from essentially different places. They'll have different profiles, even though adherents claim motivated by the same things.
Okay. My opinion really is that theists base most of their stuff on emotions. Atheists base most of our stuff on logic and reason. Feelings and emotions are substantially different. I also believe that women tend to base things more on feelings and emotions, and men tend to base things more on logic and reason. There are
Everybody bases
exceptions.
stuff on emotions, and then some people, what you call justifying or reasoning or rationalizing things to themselves. That's an ego building exercise. Nothing to do with actually being truly understanding logic, objective or quasi objective sense, and has to do with more of a problem solving approach.
I believe it is what's
Don't try
done.
to tell me men aren't driven by emotions. I mean, come on.
I don't believe that. I think you might not understand men enough or atheists enough. I think we're driven on logic and reason. Everyone has a
If
combination
that
of
was
things,
true,
but it's
you wouldn't even
what
give
is
a shit to
dominant.
talk to me right now. Just
Say
wouldn't
again.
give a shit. If that were true, you wouldn't give a shit to come in here and tell me I'm wrong. I mean, the fact that you've got to come in here and tell me I'm wrong is an emotional reaction.
No, I'm just trying to help you be aware of
No, it's
what
not. Well, yeah, it
atheists
is.
of
Well, no,
what
it's not.
you can say that all you want, but doesn't make it true. It's atheists. I'm trying to make you more aware of what atheists and men think. I think
You're
you're
trying to
looking at it
teach
from
me
a female theist position.
You're trying to
I,
teach me
I
something, eh?
personally
How
disagree with
noble.
strong atheist, and I am a strong atheist.
I
I've been called an
disagree as
atheist so
well.
many times. Oh my god, it's hilarious.
Well, it has to do with your estrogen. Your estrogen makes you all having to do with emotions and feelings, and our testosterone makes us not go in that direction so much.
Good
And
question.
that's why I have a mostly male atheist theory that most atheists are mostly male because we make our decisions based most on logic and reason, whereas theists are generally more female who base their stuff more on emotion and that's really clear
Your
to
voice
me.
is
You're making a
literally
really strong
wavering.
argument to become a theist.
Your voice is
Go
literally
for it.
wavering right now. My
Go
voice
for
is
it.
not wavering.
Oh, you
Calm.
you
I
just said
don't
all
think that's
women
the
are theists.
criteria for anything whatsoever, how wavering someone's voice is.
Is certainly
But you can try
anecdotal
to make it
support
like
of the
that.
position that you're a nervous wreck, aka being emotional, and it's
I
like,
am so scared
fine,
talking to
you have
you. It's so
emotions.
scary talking to you.
I'm sure it is.
Yeah,
And the
it
fact
is.
that I'm a woman, it's like, look in the mirror.
Okay.
People's
Any
karma
case,
wasn't
I'm at
so
work.
shit. I should have
I'll
been a
get back
man.
on when I get home from work. I have a customer, but I'll get back on when I get back from work, and we can finish this if you're still here.
Oh no.
Well, Jen we were.
It was totally
We're
my
in the
fault.
middle.
I could
I'm
visit the
sorry,
little
audience.
boys' room.
We were in the middle of a great side conversation there that I felt. I'm afraid we had a few seconds of dead air, so please accept my apologies. I do have like the very end of the stream ready to go. I don't know if you want to replay it or we can just launch immediately into questions, but he said something really cool at the end. Like right before he's like, okay, I gotta go off to this meeting. It was like maybe 20, 30 seconds.
It's always the beautiful thing because, like, Professor Wolfram, he's always running late for something. He's like, I need to go to this. I was supposed to do this. And then very often he's like, whenever he says, we need to unwind soon, or like wind down soon, very often there's another hour or so of a stream going on. Like there was a
3 hours
4-hour one last week because he had this old colleague and a couple of the things that they were going in there. And I'm like, wait, hold on. I'm hearing to the power of -5/2. And that being important. So I'm like, all right, let me scan some documents. I'm like, oh, this is very interesting. And then even I heard Gamma mentioned. Maybe he was just using it as a random arbitrary thing, but all I know is it seems like there might be something going on. I'm just like pi and Euler's number, and you just keep on following the paths and everything, and it just keeps on winding and winding, and it's literally circles all the way down.
We have
turtles.
to
Turtles are kind of circles.
We have to not confuse people. Okay, so we need to do an intentionality thing here where by the time people are at the end of this stream, they're not more confused than they were at the beginning. And you sound like Sonic the Hedgehog right now. You're just like so excited. And I get it, and I'm excited too. And all the people
is it that obvious? I'm a Sonic fan. I'm not saying that's a contributing reason why I'm a furry, but Sonic Saturday AM is probably. I apologize. Continue, Jen.
All right, so I've got a preview document here of basic idea. So do you know what this image is? I don't know if you probably can't even see it, but for the people in the audience, it is one of the ways of drawing the hyperbolic figure 8 knot. So this is the key thing to understand if that's
what you're showing right now. Why does that remind me of a wave function in some way?
Well, is it a function? No. Right.
Hold on, maybe I need to reload. Okay, no, never mind. No, the stream updated. No, I saw the 2 spider legs.
But that's the thing. Like you gotta use the right words, or it's gonna end up in the gutter. It's gonna end up in the gutter. Like the mistakes are all on this metaphysical level. I know I sound like a broken record, but it's true.
Oh, you've been doing work. You've been doing work, I see.
Isn't it so cute?
This is beautiful because this
isn't even finished, and this sucks because I suck at formal logic, so I need some help here. I can't do this all by myself.
If anything, I'd say you're better at formal logic. You basically solved most of modern mimetic theory for me while I was just saying, like literally, you actually formalized it. Like the one little part where you're kind of like, well, there was some hand waving. Those are the parts that get me. Like those are the parts that I love, and I just like going at it from every different angle. But like the rest of everything, I'm like, and I just get lost. I just get lost in the woods.
Well, sure. I mean, nobody. You know how many people have tried to do what we're doing right now? It's not a small number. It's a large number. And you want to know how many people succeeded? That is a small number. It's 0. So if we do this is probably, unprecedented. It seems easy on the surface because perceiving something is not impossible, right? But then to go to actually,
to actually formalize and be like, all right, we actually have like methods to actually show that this is true. It's like, all right, we have this, everything adds up. What's an experiment we could actually do to help to verify aside from everything else we've already done? And when you get to that point, then it's like, I've been watching some of the anti-gravity stuff within those communities. All I'm saying is, I think we're getting closer.
Why would you bring up anti-gravity now? Literally the worst thing you could bring up, right?
I ruin everything.
Well, what are we trying to stay focused on here? Is the
I'm Sonic. I saw.
axioms
Okay,
of the
we'll stay to
hyperbolic figure eight, the
we'll
axiom,
stick to space time. I'll mute
right?
my mic.
Because space-time is entangled, right? But what does that mean? What does it mean for space-time to be entangled?
I assume it's a lattice.
It's yeah, exactly. It's like, what does it mean? It just means that our diagrams are saying space and time are not entangled. They're saying that they're orthogonal. So it's essentially understanding that entangled and orthogonal are, in some sense, opposite concepts or two ends of a spectrum concept, limiting concepts. And I saw a lot of questions on Wolfram's show about Clopin sets and limits and stuff like that. It's like these things may not have a physical correspondence. And something like a set boundary is absolutely non-trivial determination of whether there's a justified set boundary. I mean, what are the fundamental things in the universe? Well, you're looking at really the only thing fundamental in the material universe, which is the quantum periodic table, which is the ball with the. How would you describe that anyway? I was like, I like went on a show and I was like blue balls, and I was like, help me out.
I'm still no. Your intuition on this. This is still what I'm trying to figure out, and this is why we totally need you, because even Thad was like, he's like, well, this will go into the periodic table. We don't necessarily know how to. And I'm sitting there, I'm like,
You're
I know
like
somebody that has a really good intuition about this, and I'm just like, go through, and this is the most amazing thing. No, I literally found like you, Thad, all these different folks literally just cruising the cosmic wave function of the internet. That is the craziest thing.
He's sitting at a nexus. Okay, on the one direction is prime numbers, the other one is the periodic table. It's like, how's that even a choice? Come on.
Wait.
Table, prime number.
Wait. Is that what you did? Because I'm still trying to figure out like how you did that. I see the 5 vector. Oh, it's gamma, isn't it?
What are you talking about with gamma? I'm not exactly sure.
The gamma function, because it's like 5.14 or something like that. Or maybe just the 5 dimensions of articulate. Oh, okay, I'm confused.
Okay, there's one thing.
I was with you a minute ago, and then I just confuzzled myself. I know. I'm trying to figure out how you got the balls in that shape.
I didn't put them in that shape. God did. That's the periodic table.
How did you conceptualize it in that particular?
It was revealed.
How did you get to that?
It was revealed to me, obviously, the only way anyone comes to know anything. Let's see here if I got the right. Oh, there we go. Yeah, it was.
How would you describe its orientation?
It's pre-space temporal. So when people wanted, this is essentially the problem we're having, is that people seem to believe that it's possible to just arbitrarily impose space-temporal constructs in the causal chain, and that's not a fact. Sort of comes to the same, basically every single problem in physics ultimately stemming from metaphysics. Like, where do we get the idea that an inertial reference frame is possible? It's not possible because that would actually contradict ether physics, which is definitely demonstrably real. So this arbitrary thing, this idea that you can arbitrarily get these perspectives that obey these mathematical presuppositions is itself a fallacious presupposition. I love that word presupposition, though.
Now you're talking about quantum fluid dynamics when you say like ether, correct?
Ether is just negative space. So if you want to call it quantum, whatever the heck, you can call it literally anything you want. I think the best word is quantropy, because it's entropy and quantum put together. Because right now, quantum doesn't really deal with thermo. In fact, contradicts thermo by having, I think it's called CPT invariance, charge parity time.
Oh, it's quantum chromodynamics. The different color/flavors of stuff and things. Yeah.
Jason's asking if my hypotheses can be written as equations. Theoretically, yes. Theoretically, my hypotheses can be written as equations, but we have to remember that equations live on the real number line most of the time, or real number lines.
Oh, I see. We should play the clip now.
What clip? Oh,
the end of the Wolfram, because you said he said something interesting, and I googled Mandelbrot.
Okay, so if you want to do that, that's cool. I'll just ask you to mute yourself, and then I can play the audio through on our end, but you have to stay muted.
And it's not just physics.
See if
because
it's
the
still
stuff will be
live.
applicable to lots of other things as well. Existing descriptions, which have been developed over the last couple of thousand years, are stated in geometrical terms. So then the question is, how do we manage to leverage what is known there, what has been discovered by just essentially looking at Euclidean geometry and its small generalizations? How do we meet that from this different perspective? I think that's the basic point.
In order to understand the limited behavior of these objects, in essence.
Yes, that's the point.
Yes.
How does how does that limiting behavior, we know there are cases where these objects limit to things which are just familiar Euclidean geometry. Okay. But the question is, when they don't limit to that, I mean, this is what my sometime friend Benoit Mandelbrot could have done, so to speak, or might have done, or something. No, not really. I mean, what he looked at, oh boy, I'm somehow yeah. I mean, what he looked at was the neighbor independent substitution system limit. Things like this that purely become nested. Except that, as we talked about at the beginning, the question of calculus. Okay, I'll give you examples of things we want to be able to do. For example, in calculus, we have tensors with integer numbers of indices.
Yes.
What happens here? In other words, for example, what is the epsilon, the totally antisymmetric tensor, which has a number of indices equal to the number of dimensions of space? What does it look like? I mean, I had some definite hypotheses about these like a year ago. I think I have some. I think that a rank n tensor is a thing that starts from a point and has sort of n-geodesic tentacles hanging out from it, and that the totally antisymmetric tensor is like saying how many tentacles can you have before you run out of room to put in tentacles, and that effectively is telling you the dimension of the space, and that's why the totally antisymmetric tensors are, that's how that whole thing comes together. But we need to work this out in more detail, and I need to go to a completely different meeting. But to be continued for those interested. This will show up in the public archive of current files by tomorrow.
Did you catch that?
It's a beautiful thing.
I know, the tentacles thing. I was like, where did he get that from?
I think the intuition comes from like black holes, because they're like, black holes don't have hair. So they spent a whole bunch of time, and Jonathan had basically modeled. He had basically taken some like their data and then was basically plotting it from like existing data and everything, and attempting to, by almost tracing out a black hole, try to gain some intuition of what's going on with the actual universe. Basically, if you could start the mapping, which is, I mean, it makes a lot of sense to grab intuition. It's like, all right, if we're able to start to pull out like general relativity, or at least special relativity, and working towards general relativity.
But I have a theory that nobody understands gen rel. So how the hell are you gonna pull in gen rel when no one understands it and everyone's just fronting?
This is why I started to withdraw and said they had special and they're working towards general, because then I realized the words coming out of my mouth and they were untrue.
Well, it's a personal confidence thing. It's like, do you feel confident with what the knowledge presented in special relativity is saying? Because I feel pretty good about that. I think it's at least it's presuppositional metaphysics don't contradict realities. Note that that's not the same as them being correct. Big difference. So, but yeah, what he was saying about the tentacles, to understand maybe what the problem is in terms of framing and Is anybody understanding what I mean when I say the metaphysical, the problem is on the metaphysical side? Okay, I just want to actually go to the audience and check out the questions because I think there are some. Did you see any? Oh yeah, what formalism is this theory written in? Hamiltonian's topology, category theory, formal logic. None of those. And it's looking like Beams, you still there?
I am.
You understand what the problem is? With how they're well, you have to think about it process relationally. What is really happening? What's really happening? Like the measurements we take, there's still something happening out there. So if our measurements don't line up with what we like, if what we think about our measurements doesn't line up with what the measurements are doing, then they're going to decouple from, like they're not going to be, the interpretations won't be correct. There's no like how do you know when your metaphysics are right? You can't, because there's no solving what they call hard solipsism, which is that you essentially have to rely on your own mind for any type of value judgment. Fair enough?
Yeah, I mean, we're trying to figure out what is truth.
Well, yeah, and to do that, you have to define it, right? And most people can't do that because real truth has nothing to do with subjectivity, and people want to believe that it does because it's comforting. But really, truth is not. If it is subjective, it's minimally subjective, and that's the whole idea, right? So we don't have to get into a big, moral.
Oh no, you got to boil. No, and this is why I'm like, this is why I like Jen, because you beat me over the head with axioms. You're like, you have no axiom. I'm sitting there, I'm like, very interesting. I have never considered this. And then, literally, like within 2 months, at one point during one of the Wolfram streams, it's like, well, what are your axioms here? What is this? And then he's talking about adding. He's like, well, computational irreducibility, is that something? Because they're like starting to analyze math and everything. And I'm like, this is getting very, very interesting. I remember having these conversations, and now I'm hearing very smart people that literally power Alexa and Siri talking about it.
Oh yeah, they're real smart. All they can do is just say the exact same things as me. Geniuses. So much for original thought, eh?
Well, I mean, everything's trying to. It's relative. It's relative. It's relative. It's just very.
It's all good. It's all. Hey,
this is why I love the internet, because you can always go back and be like, oh, wait, who was talking about this before? This is why I put all these things out there. It's like, at first, like at this current YouTube channel, it's like, yeah, I was just gonna go out there. I was gonna engage in the culture war, and I realized people are saying a lot of really mean things. So I'm like, all right, I'm just gonna do a bit more of a trolly nature, and then I start going back into the science, and I always seem to end up back in sciencey things like this in philosophy, and I'm like, all right, these are the things I find interesting. But I think even Nolan had brought up on one of the streams when I was talking about like some of the different base articulations, the hyperbolic figure 8 knot. It's like I say something, he's like, you know what? It's like, that seems completely plausible, but the way you come off, it's just people just believe you're just BSing. I'm like, that's a fair assessment.
Well, you're not a serious teacher. You're trollish, but you're a self-admitted troll. So it's kind of like Luke Ford with the porn addiction thing. It's like shitty, but at least you can admit it. So maybe in some sense, there's room in the circus for a troll or two, is all I'm saying. And sometimes,
I resemble that as well. So I mean,
like, how many actual scientists want to come and talk to me on the show, right? Because they could theoretically come on anytime, but they don't want to. But because it's just like, who wants to not know? You don't mind looking.
You didn't do well in conduct when that still existed in school, did you?
Conduct? Oh, I was very good in school. I don't like.
Okay, I take that back. It's like conduct we used to have. It's like how well you get along with others and everything. Okay, I made an assumption. I apologize.
Well, it was a bit complicated because it was important to my mom that I go to French school to be bilingual, right? So there's a limit. Plus, I'm super shy. So it's like probably hard to believe that or whatever.
Well, this is the beautiful thing about the internet and everything. Some folks, they can be wicked shy, then all of a sudden they get on the internet. Like even XX misses me. She was like this. She would just be very docile and everything, and then blah! I'm just like,
Well, I don't know about docile. I don't know if I go that far. Like I really enjoy myself, but yeah, I'm not the type. So back to the questions. Yeah, it's all about framing. So here's how we have to look at it. So here's how we're looking at it right now. There's some stuff, and we model it in these real lines, R3, R2. Okay. We don't really know what that means, but if we throw enough math at it, it'll make sense. And more or less, I think most people just aren't super conversant. Like I've not met that many people who even knew how to give a definition of special relativity. I haven't been going out and testing people. That type of routine doesn't play well at house parties.
Well, this is one of those things, unless you're really looking into it. I mean, one, you're probably not going to necessarily even know, oh, I remember that was a thing I heard somewhere before. What does it actually mean? I don't know. There's a bunch of equations and stuff like that. All right. We seem to have gotten a lot of technology and stuff out of it. But what's left? Because, I mean, even Professor Einstein said, he's like, well, we're not done. There's more to do.
Yeah, we want to avoid the trite cliches, okay? The trite cliches and the superficial, tired metaphors. It just, honestly, it's such a poor substitute for knowledge. It's not even funny. We just really need to. Just because someone said something doesn't mean anything, right? Even if that.
I mean, it's citing authority, and it helps. It also helps tell a story to bring folks in a little bit there. It doesn't mean it's true, but it can be used as a metaphor in a way. And
I want to answer Parmenides' question. Like I really do want to get to the audience questions, because ultimately, like I just want to be basically like T-Jump without the comfy chair, answering audience questions all the time. Oh yeah, minus the video games too. So my theory doesn't depend on subjective understanding. Is that what I'm saying? Is that true? Well, you need subjectivity to understand anything in the first place. So the way you're framing that question already doesn't make any sense to me. So the point is that you have to look at space and time as emergent. There's something that exists prior to space and time. And right now in the math, you're saying, well, everything is just at the same time, and space is pretty much perpendicular to time. And, these Hamiltonians are pretty much a thing. It's like, no, you're going farther away from reality. So reality is entanglement, and the principle of non-locality and localization are canonically conjugate. So they're equally true. It's kind of like with position and momentum in the Heisenberg principle. There's not one more true than the other. So non-locality and localization, again, two ends of a spectrum. What's being localized or delocalized or what have you, again, still have to get the words down pat, but it is the space-temporal observables themselves, which are subject to, aka constrained by, aka limited by, something called the measurement limit, which says that 3 plus 1 is your maximum. It doesn't go to the maximum, but it has a probabilistic distribution around the maximum corresponding to an entropic maximum. Does that kind of make sense? Like,
yeah.
It doesn't go to the full measurement limit, because that's actually precluded. Like, why is it going to the measurement limit precluded?
Well, we're only catching half of
because
it.
The Pauli exclusion principle. Yeah. Because of the Pauli exclusion principle. What is the Pauli exclusion principle?
That's for fermions. So I mean, technically, if we were using like bosons, like photons,
everything is an entangled superposition of fermions and bosons.
Okay.
So to say, well, that only applies to fermions, it's like, well, photons don't have non-trivial behavior without fermions. So the thing arising is photons pervading a fermion matrix. So there's really no separability there. No meaningful separability. You have to visualize it as kind of like a tree where the leaves are made out of electricity.
So photons don't go together? Because I remember they said it was like a clumping of photons, and for some reason I thought they were excluded, even
Clumping?
though what you said. Oh, okay,
Is
okay.
there
I see.
anything
No,
in
that
this
makes more sense.
diagram that signifies clumping to you? Clumping sounds like something, in the kitchen. It's
I don't know. It looks pretty clumpy to me.
It looks lumpy. Maybe it looks great. It looks kind of like grapes.
No. Does clumpy mean mix? Okay, now we're just getting into semantics here. Okay, no, that's fair.
What I'm saying is that the hyperbolic figure eight may somehow be the same information as the quantum periodic table, and if it is, it would be fun to say that, because if we can prove some sort of transform function between what Thad's saying and what I'm saying, that means a lot. That's a much stronger proof than what most people could do, to have some sort of cross, because it's a cross axiomatic map.
Well, I mean, it's at that point you're literally merging like quantum and like atomic there, and then it's like, all right, now,
okay, like
it's like, okay, now it's like you went from like the quantum and the bunch of what'd you say, quantropy or something like that. It's like, all right, we're going to a scale where it's like many people at least have the conceptions of, it's like, all right, you have an atom, whatever you saw in the textbooks, okay, it's not correct, but at least somebody has something in the mind. When you just start saying like the quantum wave function, people's minds just get like an error 404 very often. They're like, all right, what's going on with Dancing with the Stars, the Masked Singer? Ooh, look, a frog. All I know is that's what happens to me. It's like as soon as people's brains start to hurt, as long as you can relate it, and then if you can relate it, and then all of a sudden, if there's that spark of interest, then you can get more and more minds on this. And I tend to think the more and more minds we have on it, especially the more and more like smart folks out there, and especially if they have an interest in it, then we're multiplying our potential computational power.
And it's not a function, right?
I mean, it's all a wave function, I guess.
Well, what's a function? It's a relation defined on R. Where's R defined? Nowhere. R's not R.
Well, we don't know.
Yes, we do. We can definitively know due to the Heisenberg uncertainty principle and Pauli exclusion principle, mind you. Remember, there's no such thing as a truly unbound photon. Photons are all relational to fermion. They arise when the fermions exit the dark matter, remember? So they are completely paired, light, time.
Can you go back to the dark matter thing? Could you explain that, please?
Yeah, sure. That's on the blog if people want to check it out. This is probably one of the things that, like, if you want to point to some work that I did that might not send people running in the opposite direction immediately, you can check out on my blog, which I'll put in the chat, and then talk about it predicts it's called the Hubble's law. Well, I like canonical quantum gravity, so I'm open to suggestions. Here's the blog, and on it, it's The Nature of Space is the name of the article. But it basically goes in to show you how you get the Hubble law using this approach to space-time, because that's really what we want. We want our axioms to predict what's going to happen, or at least enable us to understand what's happening sufficiently precisely that we can make future predictions. Because to be able to predict like the whole thing, that would take a degree of precision perhaps no one ever would possess, right?
I mean, we can get this to the atomic scale. I mean,
well, that's the cool thing.
A lot more folks would probably be like, "Oh my God, we can actually do this," rather than being like hand waving.
The cosmological scale and the atomic scale are the same, because that's really the only places where the uncertainty principle has non-trivial solutions, if you want to use the parlance of modern math, which I'm fine to do, and I like it, and it's really good. We just have to realize that these constructs don't actually have any representation in reality as it is. There are subsets of reality that resemble vector spaces, and it's a very useful construct. Obviously, anyone who works in computers literally could never deny it, or knows literally anything about computers, but that, for anyone saw the argument I had with logical, floggable, blobbable, he was trying to say that, the something about computers implies something about the physics in the universe. It's like, no, the fact that we have to build a computer and connect it to a power source means that it can't possibly function identically to how the universe functions, because the universe doesn't need an external power source. So there you go. It's like, you need to do it with the information you have only within.
I'm not going to argue for the sake of time. So here's a video from the Institute for Advanced Study that came out a couple of months ago, and this is where I'm kind of going with the thing that I put in the chat. It's the corpuscular lattice oscillation. Cyclic kinesis. And what I'm essentially saying with that is basically going in with the entanglement. It's like, what if it literally is a twisted web we weave? Because
this is one thing. You have this bad habit. You have used like 4 extremely niche words in the last sentence.
I know, I'm
Try
so
to keep
bad
it
at
to
it.
one difficult word per sentence. Everybody thinks you're smart. Okay. Anybody who doesn't think you're smart isn't going to be changed their mind by you using a bunch of big words in a sentence. We're beyond that. The fact that you're willing to talk to me means that I know that you're galaxy brained.
I don't know about that. All I know is the reason why I said it that way is so I'm just saying the universe might be a clock, because the acronym comes out to be clock. And if you want to call it clocks, you can add strings to the end to make all the string theory folks extremely happy. All I'm saying is they used to say, and even there were some of the old stories.
You realize you asked me a question about quantum state exclusion, and then you jumped into this knot thing, which to me seems enormously it's not clear where the connection is.
Oh, I was trying to explain gravity.
You were trying to explain gravity.
Right.
So you're an expert on gravity, or
No.
I'm the expert on gravity?
I mean, maybe
I thought it was me.
This is why I'm presenting it to you, to see if it makes sense.
You should be trying to re-present my ideas to me perfectly accurately before even thinking about giving me a dissident view of anything, because my theory is already complete. I don't need other theories to complete my theory. I've got all the answers I need, but I appreciate other input. It's just that the knitted stitch at this time, I have no clue how to integrate that. And I just thought it'd be good for me to actually finish the explanation that I'd started.
I will need to read your blog post first.
Unless you already know this and you want to take a crack at explaining it. Because it's really, at the end of the day, not that difficult, but you have to actually know it. I'll take that as a no.
I'm just saying that if everything is knitted together via some form of a hyperbolic knot, whatever form it takes, if it's literally the base component of space and time itself is woven together, they very often will show it's like, all right, here's a sheet, here's a ball, here's a smaller ball. The smaller ball rolls to the other ball because it's literally space and time in of itself, a la the fabric. That's often used an analogy. What if the vacua itself is woven together like that? I mean, that basically ends up having gravity be emergent, right?
No, because then what's it emerging from? A rope? No, the rope is the gravity in that case. It's what, emerging from itself? You got to go.
I mean, no, you need the fermions there. You need the fermions.
You got to learn how to explain your thoughts super methodically. Cause effect, cause effect, cause effect. So, what is this a metaphor for here exactly?
I'm saying reality in and of itself is woven together within a lattice upon a manifold that likely either the figure 8 knot hyperbolic figure 8 knots complex.
What can you point to prove or give evidence to support that this is true?
I mean, Newton's laws?
No.
Inverse square law?
Okay. No. Newton's laws don't require this to be true. Newton's laws function on a basis of Cartesianism.
Okay.
This and Cartesianism can't both be true at once. Why?
You're talking about like a flat plane versus a
all throughout. You want to try to say it in actual. You want to actually try to find the words to say why those two concepts are completely incompatible concepts.
I'm not sure. Well, the thing is, this particular video doesn't necessarily even answer the video, because
I'm
when
not
they got to
asking
the
you to
end,
find the
okay,
answer in the video. I'm asking you to find the
okay.
answer in you. If space is entangled with time, is it possible to have a Cartesian plane?
I mean, is it? I still
Well,
view
what's on a
time and a lot of
Cartesian
time
plane?
as
What are they?
computation.
What's being mapped on a Cartesian plane? Just before you even put a graph, before you even plot anything, what's on a Cartesian plane?
A plane.
A real line.
Okay.
A cross product between two real lines. Yes? I mean, that's what it is, right?
You're basically just talking about like the graph. I don't know what a Cartesian plane is. I usually just look it up.
Well, we're talking about the precedence of the arising of matter. And Parmenides, I don't know what ER equals EPR, but with an observer, there is no such thing as an external observer. Everything is relational observations, and the observations are bounded by the measurement limit. So there's a limit, hard limits all over the universe, the maximum density, there's the maximum divisibility, and that all ultimately comes from primordial divisibility, which is the measurement limit, which is what this wonderful YouTuber who you should subscribe to right now is trying to get at, but it's just having a bit of trouble because it's what you call an imminent, pervasive, sort of transcendent notion that it's.
You're
Remember in
saying
The
I should
Simpsons
pay
when
more
Mr.
attention
Burns
to
was
this.
sick?
No,
No.
you're hitting me over the head with this again. The last
Remember,
time you did it
no,
made a lot
I'm
of
not.
sense.
I'm saying that this is something that happens normally, and I'm just saying it's fine. Remember when Mr. Burns was really sick, and he had so
It's
many.
like you have all these diseases that none of them affect you. So you're saying I'm invincible?
No,
No,
I'm
not at
saying he
all,
had
sir.
so many
Excellent.
illnesses that they would all try to fit through the door at once, so that he wouldn't really get sick because they'd all be sort of fucking each other over in the way to making him sick, type thing.
Yeah.
And that's kind of what it is when you have these realizations of these fundamental truths that they're all trying to get through the door at once, and you end up just not being able to get it out. So that what am I trying to say? It's like, oh, I know something's magical here, but what is it I'm really
Well,
trying to say?
the way you just described it explained the measurement problem better than anyone else I've ever heard, because that made sense to me.
Well, sure, there's tons of measurement problems.
Somehow between farts and quoting like a trope in The Simpsons, it's no, because what you just said there, I'm like, oh, okay, well, if they all can't get in there, and that's something visualizable, it's entertaining, and at least for this observer, I remember watching that on TV, and I remember chuckling at that, because I even mention it occasionally.
So the
I
way to
never
read the
thought of it in
diagram
that
I have
context.
right now, just you can go to it's better if you go to the website yourself and look at it. But the way to read this diagram right now is that it has a left side and a right side, and on the left it's the cause, and on the right it's the effect. It's not meant to be complicated, and it's just meant to show that super dense regions pump out new stars. And that's already been demonstrated, so you don't have to worry about that. But the subtler aspect is that when they pump out the star, they're pumping out like a bubble of time around that star, which is then additive. So you've got time bubble after time bubble after time bubble, which are all created in sequence. That's why you have the Hubble law, which will give you, obviously it's not going to be 100% one-to-one. And why would we know that it wouldn't be one-to-one distance with speed? Because we have quantum effects. So everything's essentially happening on a distribution, but it's not a distribution of like anything can happen. It's totally random. It's like, no, it's like when the electron's going through the slit. It's like there's a range defined by the eigenstates, by the system itself. There's a range. So yeah, but we would predict through this model that if you were ever going to see, because the probability like for a proximal system to have velocity towards you or away from you, if you're just talking about two systems right next to each other, is approximately 50%. Would you agree with that?
I mean, it depends on what's happening around that. But I mean, if anything else, I mean, you're going to have whatever. See, my base thought was whatever you're essentially trying to measure. If you're traversing perhaps a hyperbolic manifold or something like that, if you require 720,
You're
and
not
at one
traversing
point
a
you're
hyperbolic
inside.
manifold. You're traversing ether. There's no traversing of hyperbolic manifolds on this level. We're talking about just pure mass and ether, which is negative space, aka just nothingness, but taking up a volume. So not pure nothingness.
So
that's
be below the level of a fundamental manifold.
It's literally empty space. Just don't try to think it's more than empty space, because if you do, you're going to sabotage your own understanding. Like, ether's not complicated as in and of itself, but how ether applies to physics is not that easy, because there's not a conservation of ether, but there's an approximate conservation of ether. So every time there's an exclusion event, like we have in this diagram, there's ether that's created, and then that's the part at the bottom where it says the size of created space. And I'm sorry this isn't coming through like awesome on the stream there, but it does look better on the blog, and it's a lot more clear. So between exclusion events, the amount of ether that exists is the same. Why would it change? There's no mechanism to increase ether except for exclusion. So if you can see how quantum state exclusion creates ether, then you can see how there's going to be a general tendency towards expansion. Because even though gravity ultimately contracts things, essentially exclusion expands it more than gravity contracts it. That seem okay? Literally there's no manifolds at this point, because we haven't entered temporality yet. This is not a temporal system. It's only a causal system. Time is not here. Time has left the building.
It would explain a lot. Actually, this explains a hell of a lot then. Let's see. So where does nothingness come from again?
Well, there's no such thing as nothingness.
Okay, but
it's just that you want to. People will have trouble maybe when they first start learning about ether, and they're going to be like confusing it with void, which is what you call nothingness. But if it's like, well, where's the void? It's like, well, it's nothing, right? But the thing is that nothing has a metaphysical effect. If you believe in something that has no representation in reality, that has an effect.
So the nature of entropy itself is the reason the universe is expanding.
The cause of the expansion is exclusion, not entropy.
It is exclusion, but exclusion, as far as we know, it ends up
expansion.
What I'm saying is, if everything is going to end up having to a level of complexity in and of itself, one would at least assume that if you're going to continue to get complex like that, then the universe would just keep on expanding. I'm making an assumption.
You lost me.
Okay.
You lost.
No. The nature of the universe to follow entropy, if it's going to become more random, if it's going to become more complex in
we need a definition of entropy, because you're conflating randomness and entropy.
Okay.
Disorder is not randomness. There's no such thing as randomness.
Okay. So
there's order, disorder, entanglement, locality, and non-locality, which again relates back to entanglement. So the concepts themselves are not independent. They're like each other's kind of limiting points. So that makes it very difficult to work with systems like this. Parmenides says that my theory sounds like Leonard Susskind's. I have heard of him, but again, like, I don't really care to research other people's theories unless they've met a certain standard of proof, like that guy.
I mean, Professor Susskind did win a Nobel Prize and stuff. He used to be a plumber too. That
literally couldn't make less of a difference to me. Like, someone's personal life, I'm happy, whatever. Really happy to share philosophy with people, but frankly, your personal experiences don't mean a whole lot. It's the knowledge that you have and what you can back it. Can you actually back up your positions with an actual argument, a defensible argument? So yeah, does consciousness cause collapse? No, consciousness doesn't cause collapse. That's nonsensical, right? Because the collapse and the consciousness are indistinguishable by the very definition of the Copenhagen interpretation. So this idea that the observer, as in the person carrying out the experiment, is somehow responsible for the outcome on some fundamental level, that's moronic and false and nonsensical again. It's like, no, observation is what's happening in the measurement device. The measurement device is interfering with the system. That's why it's able to display a measurement. It's just like, what does that mean in terms of how it's disintegrating the signal? So the
It's the
signal,
Mr. Burns thing. Only so much can get through.
the signal doesn't dissipate due to entropy. There is a limit to how many observations can be made upon a system, which all systems are waveforms, and you can't do more than 3 plus 1 perpendicular or observations on any waveform per order of magnitude. And that's all there is. But then the art is to sort of see where that is applying to your physical system. Because I think this will work for general mechanics too. Like, it's not just quantum mechanics, because it's really a coordinate system that you could theoretically apply to everything.
So expansion arises as a consequence of disorder.
Again, there's no disorder. That does not exist. That is a myth. It has never existed. So why do you keep bringing it up?
Because you corrected me, and I was hoping that was a quick out.
Quick out? No, there's no quick outs. There's no. There's total conservation of karma.
Well, you just rephrased. You just reshaped my view of the universe yet again. So
again? Oh, you're making me blush over here. I feel so happy.
No, because this. I do a couple of things. I just took in, and I'm just like, all right. I'm like, this model is making more sense. It actually seems to explain a lot more. So I'm very happy with this. But I
it's okay to cry about it. I've definitely cried about it. I was like, it's so beautiful. It's so happy.
No. If we can take some of what Thad's done there, that with what you've done with the periodic table, if we can literally have this linked to the atomic scale, it's all I know is I wouldn't mind a tic tac. I know,
cool. It's like, this is something funny in the chat. So there was nothing, then something appeared because there was nothing to prevent it to appear. This is sort of on the right track. Like, it almost sounds like a Zen koan, but the way that I would express this is that the minimum energy state is not zero. Like, the zero energy state isn't actually populated, basically.
What Bub said right there. It's like that's kind of Professor Wolfram's intuition about like how you could get something from nothing. It's like, all right, if you have nothing,
because we're already less than zero.
All I took away was something about like, if you have an infinite number of rules by like another infinite number of rules, eventually you're going to get a couple of things that go, and then like click.
So Parmenides, the way you're asking that question is itself ill-framed, right? So what is the measuring device entangled with? So the fact that the measuring device is solid means that its constituent waveforms have to be entangled with each other to a point where they're adjacent to the maximum entropy or minimum energy state. Okay, so that just basically means that your measurement device is approximately, it doesn't really change throughout the experiment. So its entanglement effects on it sort of, what is it entangled with? Well, it's entangled with itself. And then the electron comes, and the measurement limit applies everywhere, but there's no evidence that it applies until there's actually a funneling into somewhere where the measurement limit would become observable, which is a very tiny delta x in the sorry, there's just so many words. The slit that the electron's going through, right? So that's where the whole non-determinism thing comes. We don't know, only statistically know where the electron's going in advance of observation. So the entanglement has to do, entanglement comes into the picture when we're talking about more complex systems like humans. Like, if you look in someone's eyes for 10 minutes, it changes your brain waves. That's a demonstration of the entanglement principle, that it is possible to have the various, whatever you want to call them, nodes, harmonics, eigenstates of mind, passing energy between each other with various levels of efficacy or efficiency, or however you want to word it. that's where entanglement's really important. When you're talking about a simple primitive system like just a measurement device in a lab, i.e., I always bring up the single slit experiment. When you're talking about that, that's just a demonstration of the measurement limit itself, is that there's only so many things in each dimension that this thing can be. And when you reduce the range in one, it flattens it out into the other. So what started out as a sphere goes into being approximately a disk. Why? Well, because it was reduced once in its dimensionality. And how many more times could it be reduced? Well, it could be reduced as many as 3 plus 1 times, but it's probably never going to get anywhere near 3 plus 1 because that would only be at the actual total limit, i.e. like element 118, where literally everything was completely jam-packed and there was absolutely no more room. And the ether was basically, there was minimal etheric density, right? So the whole of everything is just a question of what its etheric density is. How much mass is there per unit ether?
This is fascinating. All I know, I actually got to run. I got to go visit the old man. He just got out of surgery. So, but
I
this.
I hope he's doing better, and tell him.
Thank you. All I know is you may have just made the anti-gravity people so very happy because I think you just explained a lot. But
really?
hey, we're gonna have to discuss this more in the future because I'm very excited about this because I gotta go. I gotta do stuff
No
and things.
problem.
But hey, I love you all. Peace out, everybody. Be safe. Long live the Oboe Bump. Boop.
Yeah, I can take some questions in the chat if anyone wants. He's a great guy, but he's a bit scattered, so I'm pretty serious. If anyone has any serious questions about physics or anything, I'm down to take them. But just a quick warning: you may not like the answers, but I do think they're comprehensible. If that's any consolation, and over time could certainly learn to work with them. Wouldn't take long to learn how to do chemistry in this manner, because it's just a matter of looking at the probability of microstates being filled, and we can predict the probability of them being filled because it's all about energy. It's like because the more you go to the measurement limit, the more the universe pushes back on you. It's just like, no, it's the limit. Like, don't even get close to my limits, right? So you want to, that tension is coming from the universe itself, which just sort of has this unchanging rule of thou shalt not have more than 3 plus 1 observations per canonical order. Now remember, I said observations, but we're presupping that we're talking about space-time observations. But we also sort of understanding that space-time, the way we understand them, is largely a consequence of our own consciousness, not the world. Like, there's a lot of stuff that really just doesn't have meaning outside of us, and vice versa. Hey, Duvid. Yeah, I guess it's been easier because now there's actually conversations to have with people, like sort of engaging with various extents my ideas, to various extents with my ideas. Yeah, and I'm also debating possibly on modern day debate about evolution, so that'll be super fun. So Bob Elvis asks if the universe gets updated to the next state all the time, only whenever there's an exclusion event. So there's not a constant stream of newly created stars, because a star could only be created if the circumstances arose that would necessitate its creation, because it's only created when there's an excess of mass in a particular region so that it can't fit anymore, in accordance with, remember, the Pauli exclusion principle. So Pauli exclusion principle tells us, I've said this before, some people disagree with me, but I do think it implies a maximum density per, okay, I'm going to forget the word now for this, but state variables. See thermodynamics. Yeah, I think they're called state variables, but the maximum density would change depending on the circumstances, but there will exist a maximum density state per state variables. Does it get updated constantly in different places? Yeah, it's just basically there's more ether every time there's an excluded star. Because when there's an excluded star, you're not just getting the star's worth of ether, you're getting the star and all of its everything orbiting the star's worth of ether. So when our star was created, it was like star and then do all the planets basically at the same time. That's why they're all measured as being approximately the same age. So very easy to demonstrate that this stuff actually does represent reality. So that size, the volume of our solar system didn't exist until the sun was excluded because of a situation of it being unable to be included in a dark matter region, which, as I mentioned earlier, is non-temporal. So once it's squished out, it gets temporalized and luminized, whatever you want to call it, able to transfer light. And that's basically the same thing, right? Because how do we know how much time has gone by? Well, it has to do with the half-life of elements, which are radioactive, which is essentially a light signature, right? Because it's all electromagnetic. So the way that things are dated is because they contain this light signature. Can't have time without light. And then when the light runs out here, well, we'll go back to the non-temporal phase. There's an ongoing, I don't want to say constant, but an ongoing cycling between temporality and non-temporality. And when you understand that, you have all these bubbles coming up around the center of mass, that the youngest bubbles will be adjacent to the center of mass, and then the oldest ones will be at the farthest away. And that's how you can start to predict what we observe with regards to Hubble's law, because it's never going to be a direct predictive. Like, you can prove that it's not going to be a direct, perfect, equation, right? Because there's quantum effects, because these exclusion events are really happening on a probabilistic basis. It's the same principle as the slit experiment. You can't know other than this probability. Like, we can map out the mass distribution and say, oh, okay, well, this seems to be moving towards here, great attractor, et cetera, but we're sort of, we can only know what's happening to within a band. So we want to compare that with the Heisenberg uncertainty principle, where we don't know where the electron's going if it's going through a slit of sufficiently small delta x, because it triggers the uncertainty effect, which gives you large delta p, which fans it out. All right. Is link in bio? Where did this person come from, I wonder? Matter can't be where other matter is. There's no reason to believe it has anything to do with maximum density C. You're just asserting a negative there. That's not actually an argument. So you could have just not said anything. You know what I mean? So Bub Elvis asked us, so ether gets created when too many stuff plans to be in the same place. Yeah, well, because of gravity, right? Gravity's just like the the fat kid with the cookies is just always attractive. It's just come here. But then eventually it's just, there's a limit intrinsic to ether itself that says, like, thou shalt not be more dense than this. So, matter can't be where other matter is. Okay, so there's limits on density of matter, but that doesn't mean there's a maximum density of matter. It's like, why don't you just think about what you said for a moment there? So this is definitely quantum cosmology with hierarchy of measurements, with quantum entanglement at the base level of measurement hierarchy. Well, what's at the, there's no real, I don't want to say there's no base, but when everything is dealing with cycles, there's a bit of a problem with starts and stops. I just want to, maybe I'll just reread that question to make sure I'm understanding it correctly. The base level of the measurement hierarchy. Well, you can impose a hierarchy, but there's no real hierarchy. Everything's immanent. Everything arises at the same moment. And then various observation devices can have little niches within it that they're more tuned into, right? Like this idea of us seeing the colors of the rainbow. Well, why do we see that many colors? Is that something about us, or is that something about the rainbow? And it's it's because of the universe having the measurement limit that you can really only have so many meaningful divisions in matter. And so 7 colors corresponds to 7 rows of the periodic table, which is what I tried to illustrate in this diagram here, with these white lines here on either side, that this shape isn't just about chemicals, it's about everything. And this is not the totally 100% shape, that it is then sort of stuck inside a sphere again, because the sphere is the ultimate supreme maximum entropy state, and the universe favors maximum entropy states. So Bob Elvis is asking, what happens to the stuff that adjacent to where the new ether is created? Does it get compressed? No. It just gets, there's, again, I understand the question, but you're misunderstanding what space and time are. Like, space-time only exists within these bubbles. So there's nothing to, compression only happens in space-time, because compression has to do with volume changing, right? So you have to remember that most terms are defined space-temporally. And if we're going to go into the things that arise before space-time, we can't impose the space-time constructs on them, because that's where we get into trouble with stuff like understanding quantum to this extent. But no, there's no compression. Like, you got to remember, be careful with stuff like compression. Like, compression can only happen under very, very specific circumstances. So remember stuff like Le Chatelier's principle, the least action principle, and also if you like thermo, I would say the Carnot engine. So yeah, that's what I would sort of just be careful, because there's no such thing as free work. That doesn't exist in our universe. So compression, if you want to talk about compression, you got to say, well, what's the compressor? What is giving a shape so that another thing which is expanding can hit into and become, quote, compressed? Yep, you're quantizing. I don't know how to pronounce that. I want to say Gerda, but I was probably way off. Theory of colors. Oh, okay. Great. Somebody thought about what I said before I said it. That's always nice. So I can just mod you in and you can share it if you want, because I don't know where to find this. I don't want to start looking for stuff on the internet while I'm live streaming. I'm not the greatest at what is it, monologuing, but it's something I've been working on. So yeah, what would help for me is for people to just keep on throwing out questions, especially about this quantum stuff, because it's I know it sounds a bit out there, but I'm definitely right. No one's disproven me yet. No one's going to disprove me. Why continue to fight it? Just try to understand it better, because obviously there's a limit to how well I can understand this alone, especially when I'm constantly having to field questions like, just because the Pauli exclusion principle is the thing doesn't imply there's maximum density, when indeed that's exactly what it implies, right? Just saying something isn't true doesn't somehow make it true. It's like, that's not an argument. That's a statement. Let's keep it to arguments. Yeah, quantum prism gang and light crystal gang. That's going to be that's the future. Is people getting triggered because math has become, or rather, I should say, physics have become somewhat. I believe the word that people use is hippie-ish. Physics is like economics, that we expect it to be normally distributed as we modeled it, so that math. Yeah. I'm not sure I understand what you said, but it looks like there's no more questions, which is kind of disappointing for me, because there was a lot of questions on that Wolfram stream that I was definitely going to be able to answer. But yeah. So let's just finish up with this cosmology thing. that's basically it. That tells you how it works, and everything is a combo of exclusion and gravity. And then when you get into temporality, then there's electricity as well that operates. Entropy operates pretty much honestly not at all in this environment, because there's like, what is it that makes entropy a thing is really friction, and there's almost no friction in space. So what appears to be perhaps entropically motivated, aka this expansion thing, that's just because what's being created has a non-zero velocity, and these velocities are existing in a lattice which is constantly growing from the center. So there's always more space for the velocity to expand into that wasn't previously penetrated. So it really is bubbles. Every new solar system is a bubble, that the edge of that bubble represents a sort of, as close as you can get to like a different reference frame or what have you in this universe. But it's not a truly different reference frame, in the sense that the only thing that really shifts any type of reference is this creation of ether when there's an exclusion event, when there's a star created, because it's effectively creating a velocity vector in the star, which is increasing the amount of perceived velocity. Not just for that system, but for every system, every other system in the intermediary, because they're just like a bunch of bubbles basically touching up against each other. There's no pressure or compression. It's like in a foam. They just sort of sit there in a undisturbed, perfect, maybe like an arrow bar is a good example. And yeah, it looks just like the quantum periodic table. So that hopefully explains it a little bit. And in terms of how this would link up with the other theory for the guy who's been working more so with Wolfram, which is Thad, it appears to be the same cardinality. Like 3 + 1 is also the cardinality of his system. It just comes out differently because he's actually used vectors and matrices and stuff, whereas I'm basically just trying to use forms so that there's no obligation to use mathematical equations. Not that they're, not that somebody couldn't come up with some math equations, but I'm actually more interested in it being expressed in a type of a formal logic manner. So that'll probably be where I'm going in the future with all this stuff. And hopefully it can be helpful to implementing things like what's on Wolfram's mind and the people that he works with, because it makes me sad to see people get frustrated and not be able to find the solutions, when the solution probably could be aided by what these computers can do. And they're already sort of starting to demonstrate the measurement limit, because the fact that it's possible to solve systems with this eigenstate decomposition on these pre-labeled sets implies that most of the information about a species is held in its archetype. And then we can go a step further and say, well, these archetypes have a complexity which is restricted by the measurement limit. And so you can know before you start to take measurements approximately how many dimensions of information your system ought to contain if you took all those measurements perfectly. And so it gives you, rather than just saying, well, we're going to work with a R3 and try to create something out of R3 to make that have correspondence to reality and a theory come out of that. No more R3. It's simply the arising of things that are sphere-ish. The primary instinct or primary drive is just to be a sphere, but then there's any number of obstructing things which could deviate it from a sphere, but that's what its primary desire is to be, because the sphere is the state which minimizes the torque relative to the center of mass. And just like the ancients said, there's this never-ending vibrational impetus in matter. And that's where we get into this, coming back to this idea of like less than zero. Well, zero would be if it wasn't moving, it was just a circle. 0 would be it not moving in a circle, but in our universe, the perfect circle is not observable because of the measurement effect. So this measurement effect makes it so that the 0 point energy is actually empty because it's sort of a Platonic state, like a perfect sphere, that there's a perpetual expansion towards it, but it never reaches the asymptote. Are black holes impossible? Well, any singularity is impossible. I mean, if you need to invoke a singularity, you're not really playing by the rules. Physics is about laws, and a singularity is basically saying, well, there's sometimes the laws don't apply. That's self-refuting. So you can definitely have limits. So you could infer from this manner of looking at things that, yeah, there must arise regions of, relative to anywhere else in the universe, higher density. And I call those hyperdense regions. And they should be the places from whence novel stars are being created. And that's been, I can try to find that article, though I didn't think I'd be talking about this, but let's see if I can find it. It came out some time ago. It's stars in, I think they might be saying black holes, either that or neutron stars. Oh, they're actually calling them black holes. So maybe we could say there'd be like a black hole-esque entity, but that it wouldn't have a singularity. It would just be the maximum density region. So this is a prediction of my theory here. So we have, and note that 2017 was the first time they observed this. So I definitely have been saying this since 2015, and it took to 2017. So it's, yeah, peer review, right? It's like, well, this couldn't be peer reviewed, but the idea to do it this way, is that going to come from a peer or not? Maybe not. So yeah, this definitely been validated. So it's a prediction, right? The model says that the stars should be created near maximum density region, because where are we going to have non-trivial uncertain or exclusion effects? Where are we going to have proof or evidence? We're going to have evidence in support of the fact that the Pauli exclusion principle is a thing. Well, in a place where there's maximum density. So now you're sitting in here in the chat saying, well, no, you don't need to have maximum density. It's like, well, how can you be so darn sure about that? This is not the way. Saying something is true doesn't make it true either. You got to remember that. Oh, advice. And we all know how much I love advice from random people. It's so great. Black holes approach infinite density. It's like, Lincoln, I have a degree in physics. I know. I don't need any explanations. If you disagree with what I'm saying, I would suggest just thinking about why, because I have been exposed to all the same theories as you, and yet I've rejected some of them, and you're just repeating to me the same stuff that I read back when I was in first year. So it would appear I already know all that stuff, which would imply the only way to get me to change my mind would be to actually understand my position and then defeat it, which cannot be done. Because a position that can predict everything is not incorrect, and it is irrational to believe otherwise. So that's really where people have to realize that, yeah, there's an emotional component to this stuff too. Like if you're super attached to something being true, then you're not going to be able to get to the right answer, because you're going to care more about thing you wish was true being true. So you're going to put a bunch of energy into upholding that illusion, and you're not going to learn anything. You have to make a choice at some point. Well, yeah, I'm going to respond to all the stuff in the chat. Sure. So Parmenides wants to know, where does the quantum crystal come from? Where does the periodic table come from? It's intrinsic, right? Oops, that's the wrong one. The periodic table is just there, but it's not really there in the non-temporal zones, right? So the temporal zones are a small subset of the total universe, which arise as a result of quantum state exclusion because of gravity collapse. And then as a result, you get some new states which are really far away from the maximum entropy state, because that's what's happening. That it's like the maximum density has been reached, and the universe needs to like fix the fact that the maximum density has been reached, so it'll move stuff away, and in so doing, that's where your expansion is coming from. All right, so if we don't have any more questions, and yeah, I'm sorry for being short and with people in the chat sometimes, but there's a lot of trolls that come to this channel, and I've been, dealing with that for a while. So yeah, I apologize. I'll try to chill out. I've got new settings on my comments in the chat so that only people who are subscribed can comment. So that's actually helped with the trolls a lot. So I will work on trying not to be so short with people in the in the chat when they're just trying to explore their ideas. I do appreciate it. It's just that, like, yeah, you're not going to teach me anything. No offense, but like, I never even learned anything basically ever. I already knew all this stuff. I just learned physics so that I could prove my religion is awesome, which I think I've already done. And yeah, Parmenides, you and I have been talking for a while. Like, I hope you like my ideas. They're on my blog. Like, they're really not meant to be confusing, but I think it can be a bit, I don't know. It's almost like a completely different perspective. But my latest article is really just diagrams. So it's difficult stuff. There's no question about it, but it's meant to be fun. And to me, it is a lot of fun. We'll just pull that up. And oh, that's another thing I have is I don't think I actually have any videos of that, but I have my light balls here that I designed, and I can predict the shape of DNA, much to the chagrin of many people with these things. I guess stuff being too simple offends some people. Oh well. So here's a basic overview, and this is going deeper into what we just talked about, which is cosmological quantum state exclusion, which is what creates your new stars and stuff. So I'll just throw this link in here if anyone wants to check it out. Have fun with that. And again, I'm always open to questions. There's really no such thing as a dumb question, especially if you're just starting out. It's probably takes a while just to take it all in, but basically the diagram is just trying to encompass all the information in a relevant way and keep it really light on information heavy, but light on maybe too much confusing terminology. And then same here with this one, when we're talking about trying to see what's the operating principle behind all these things. And it's the measurement limit, and realizing that the measurement limit's always the same thing, but that it has different niches. So one niche is the plant niche, and one is the animal niche, and so on and so forth. And they're all operating within the confines of the measurement limit in what you could call complementary ways. And so we have cells, which are minimally complex, and they have that shape. And then as the shape becomes less sphere-like, the organism becomes more complex, basically. And you call that a folding or a stitching. There's different words that you can call it, but it all comes back to this basic idea that you're starting out with something that's 3 plus 1, and ultimately it's remaining 3 plus 1, but it does have a range of variability within its 3 plus 1 observables. And where it ends up settling is predicted by entropy, because every system tends towards a maximum entropy state. It's just that when we're talking about interesting systems like biological systems, it's more complicated because there's energy coming in too. So this is really just meant to show that, yes, obviously plants are conscious and they're alive. I just feel like I have to repeat that because I've had some debates where people actually deny that. But they just experience time differently. Probably could say like on a maybe slower scale, just from how slow they move. And let's see here. Okay, and then I have some breakdowns of how to do advanced logic, which is really always going to turn on the strength of your definitions. You need definitions that you can defend, axioms you can defend, while also remembering that you can't prove axioms. Axioms prove things. But you want to demonstrate that your axioms are valid. Otherwise, you're always sort of, that's your ultimate weakness. And that's why everyone's losing these debates to me, is because their metaphysical systems are trivially easy to me, and they can't even begin to scratch the surface of understanding how I come to my conclusions, and are too proud to just learn and then, okay, yeah, wow, cool. And then we could just spend the time talking about how cool this stuff is rather than have to have a LARP debate about it, but whatever. It's fine. Here's like a not great diagram of how the bubbles of time are formed, just one after the other, and sort of try to like do a spiral shape, which obviously wasn't great. But the key takeaway here is that the centroid's the maximum gravity region. It pumps out novel stars. Those stars are youngest when they're most proximal to the centroid, which will just keep on pumping out more stars, and it'll get farther and farther. And then as it goes, it has basically one velocity localized from a range of possible velocities corresponding to total energy of the excluded region. So there's some range of possible velocities and some range of possible directions. And once those are localized into the stars and planets themselves, there's really not a whole lot of impediments or friction to that ongoing velocity, just keep it on going. I think this is Newton's law that like there's what is that in motion tends to stay in motion. And what is at rest tends to stay at rest. That's the inertia principle. So there's basically nothing but inertia cosmologically. And so these entropy effects don't really count for anything, which is actually very interesting because you'd think that would, but no, it's just really naturally expanding through the way the distributions of the velocities, because each time, if you're adding a new velocity each time, well, yeah, that's a net overall expansion of everything. But then obviously not perpetual expansion, because have to remember that temporality isn't forever. Eventually the light burns out, no more time. Things go back down to the non-temporal, the mass goes down to the non-temporal state, becomes dark mass, dark matter, whatever you want to call it, and then begins the cycle anew. So that would no longer be contributing to any more expansion. But you still have ether, which is perpetually created. And there doesn't appear to be any mechanism to get rid of ether. So this may be some type of a quasi-proof of universal perpetual expansion, provided you'll always have a region of sufficient density as to precipitate quantum state exclusion. So again, yeah, not hard at all, right? All right, let's see here. Threefold entangler. I like it. I like it. It's a stratified measurement hierarchy with emergent phenomena. I like that one too. Quantum exoskeleton. Good, good. Bubbles of time is like Piaget's theory, but I've applied it to galaxies. I am not too familiar with a lot of these ideas, but I appreciate the support, and hopefully people can check out the blog and then get back to me and tell me what you think. I will probably be debating on evolution. I wanted to debate 25 people at once on Modern Day Debate, but the channel owner doesn't think that's a good idea. So I'm hoping it'll just be like more than, one person, but maybe it'll just be one person and another Socratic spit roast like last time. But anyway, this is probably the most important thing that I came up with, and it explains how your mind arises with light. And there's a conservation of light in a sense. So that's definitely worth taking a closer look at. And I'll be defending this, hopefully, if I can get away with it on the modern day debate. And I tried to make it an even better secondary explanation because I realize my explanations are just, there just seems to be something missing from them. Here we go again with the measurement limit. It's 3 plus 1 into 3 plus 1. So that's why it's always, there's just an objective measurement. It's always two systems interacting with each other. And then where you distinguish one system from another is somewhat arbitrary. So we have this transcendent notion of 3 plus 1 into 3 plus 1 being a limit. Yep. So there we go. And then if there's more specific questions or whatnot, like I'll try to give a better explanation of how my theory actually predicts quote unquote evolution when I go on this debate thing, and hopefully work that up with Dubit in the meantime. So yeah, if there's no more questions, I'll wrap it up. And thanks to Memes for having the idea for having this little chat stream. And for those of you who stuck it out, I appreciate it, and hopefully see you again. Just give it a chance, you know, just give it a chance. It takes a bit of time, but I'm reasonably certain that this is the way to go, and we can all go there together. It'll be great fun. Great fun.
Yeah, but it's just so to say, a worthless opinion of.
It's so important that she can't be told. She won't be told that it's wrong. And
bringing it back to Church of Entropy and her attack dog Gandalf the White.
Why don't you learn to shut up and fuck your goddamn logic?
They control the media, and the media is capable of making the sheeple believe in anything.
Yeah, I don't mind. I mean, we've had these streams, and I've been doing with Church of Entropy, and she's been bringing on new people, and like we did those streams on like stream etiquette. We walked through like the technology.
I have like very strongly negative opinions of the kind of Brundle clique.
Is she trying to garner herself cult prestige by associating herself with a retard?